And here's team round number 4. At a carnival, Brad throws darts at a target composed of 10 concentric circles. Each of the 10 circles C sub k for positive integers between 1 and 10 has radius k, and a dart landing in the region inside C sub k but outside C sub k minus 1 earns 11 minus k points. Given that each of Brad's 20 darts lands at a random point inside C sub 10, the largest circle, compute the expected value of the sums of the scores of all of Brad's darts. This is one of those problems that looks really scary, but is really not that bad, okay? So what we've got is we've got a dartboard made of circles, right? Circles with radius 1 through 10, and you get 1 point for landing in the biggest circle, or 2 points in the next biggest circle, or 3 all the way up to 10. So what's the expected value for each of Brad's darts? It'll be the same for each one, so we can just find it and then multiply by 20. What's the probability that it lands inside the largest circle? Well, he always hits the target, right? So he's got a guaranteed 1 point per dart. That's a 100 out of 100 chance, because the largest circle has area 100. Well, it has area 100 pi, but like this is all probabilities. We don't need to worry about pi's, and they're hard to write, so no pi's happening, right? 100 pi out of 100 pi is the same as 100 out of 100. What's the probability that it lands in the next circle? Well, the next circle has radius 9, so it has area 81. Well, 81 pi, but again, canceling the pi's. So we've got 81 out of 100. And why am I adding these together? Well, it's because he gets 1 point for landing inside the largest circle. And then if he also lands inside the next circle, he gets 2 points, which is 1 point for being in the larger circle and 1 additional point for being in the next circle. So this problem is a lot easier if you think about it this way. You get 1 additional point for each circle you land inside. Otherwise, you've got to find the chance that it lands like inside the 4th circle, but outside the 3rd circle. That's just going to be bad. It's going to be worse. You can do it, but I don't recommend it. So anyway, 81 out of 100 that it also lands inside the 2nd circle. 64 out of 100 that it also lands inside the 3rd circle. 49 out of 100, right? All the squares, all the way down to a 1 in 100 chance that it lands inside the smallest circle in the center of the board. Okay, so that is 100 plus 81 plus all the way down to 1 over 100. Now you can add these all up. It's actually not that bad. There's 10 of them, right? You can add 10 numbers, but it's a little bit easier if you know the sum of squares rule. I personally actually always forget the sum of squares rule, but if you know what it looks like, you can find it by trial and error. And it is in fact, we're adding from 1 squared up to 10 squared, so that's going to be 10 times 10 plus 1 times 2 times 10 plus 1, all divided by 6. Yeah, so if you remember, it's got like 3 terms and they look vaguely like that, you're probably fine. By that, in this case, 10 times 11 times 21 divided by 6, that's going to be 5 times 11 times 7, right? Cancel the 2, cancel the 3, which is 35 times 11, that's easy, 385, which is 385 out of 100, let's not forget that. And that is the expected value for 1 dart, but he's got 20 darts, so it's going to be a much larger expected value, right? The darts are all independently at random, so we've got 20 times 385 out of 100, which is 385 times 20 over 100, right? And 20 over 100 is 1/5, so that's 385 over 5. We actually don't need to calculate that because we got 385 by doing 5 times 11 times 7, so we can just take out the 5 back there, and it's 11 times 7, which is 77. So it actually comes out to an integer, which is kind of fun. But yeah, that's his expected value for all 20 darts. He expects them to sum to 77.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.